Question 4 reads, the sketch below shows a tow truck of mass 2,500 kilograms pulling a car of mass 800 kilograms up a rough inclined surface which makes an angle of 30 degrees to the horizontal. I'm just going to fill in this information here. So the truck, 2,500 kilograms, the car, 800 kilograms. The angle is 30. The coefficient of kinetic friction between the car and the surface is 0.25. So mu k is 0.25. The net force acting on the truck is 1520 newtons. So F net is 1520. And the tension in the cable is T. Ignore the rotational effects on the wheels. Okay, so 4.1.2, draw a labeled free body diagram showing all the forces acting on the car. Okay, so while the car is on that incline, it's being pulled up by tension force. There's the force of gravity going straight down. There is the normal force which acts perpendicular to the surface. And of course, there is friction going down the slope. Question 4.1.3, calculate the kinetic friction that the car experiences as it moves up the surface. So kinetic friction, so Fk is equal to mu k times Fn. Now we don't know Fn, however, we know that Fn is going to be equal to Fg perpendicular. Now Fg perpendicular is equal to mg cos theta, if that's theta. So we can substitute that in. So mu k times mg cos theta. Let's substitute in. So mu k was 0.25. The mass is 800. Gravity is 9.8. I'm just going to continue below, and then it's cos of 30 degrees. Let's enter that in the calculator. So 0.25, 800, 9.8, cos 30. The answer here is 1697.41 newtons. Okay, so we know the friction. Let's just enter this in here. So friction is equal to 1697.41. Okay, question 4.1.4, calculate the tension T in the cable. Okay, and for 5 marks. Now what I want to do is I'll start with the truck. Because we know F net, we know M, we can calculate A. So for the truck, we'll say F net equals MA. F net is 1520. That's equal to 2,500 multiplied by A. That means that acceleration is going to be 1520 divided by, the answer here is 0.608 meters per second. Now, since the truck is pulling the car, the acceleration for the car is also going to be 0.608 meters per second. So let's put that in as well. So the acceleration, 0.608. Now let's work on the car. So for the car, as it's moving up the slope, the forces, let's choose up as positive here. So we'll say F net equal MA, the tension force minus friction minus, don't forget about the component here, that is mg parallel. So minus mg parallel is equal to MA. Now let's do our substitution. Remember, mg parallel is equal to mg sine theta. So we can substitute now. We don't know tension, so leave it as T. We know friction is 1697.41 minus M. So the mass of the car is 800 times 9.8 times sine of 30. And that's equal to 800. And the acceleration is 0.608. It's a bit cramped, but let's solve. So let's simplify first. So minus 1697.41 minus 800 into 9,8 times sine of 30. So that is equal to minus 5617,41, and that's equal to 800 times 0.608, 486.4. That means tension is equal to 486.4 plus 5617,41. So the tension in the rope is 6,103.81 newtons. Let's now move on. A spaceship with its engines cut off is moving towards Earth. Okay, so let's say that's Earth, and we have a spaceship right here. The mass of the spaceship is 1250, so 1250 kilograms. Now also, we do need to use the mass of the Earth. So the mass of the Earth is given as 5,98 times 10 to the power 24 kilograms. State Newton's law of gravitation, we'll leave that out. Calculate the distance between the spaceship, so here, and the center of the Earth, so here, when Earth exerts a force. So force is equal to 2,458 newtons on the spaceship. Okay, so we can use the Newton's law of gravitation formula. So F is equal to G m1 m2 over r squared. Now we want to know what is the distance, so we want r squared. Let's switch these. So we'll say that r squared is equal to, and now let's substitute. So the value for G is 6,67 times 10 to the minus 11. The first mass is 1250. The mass of the Earth is 5,98 times 10 to the power 24. And that's all divided by the force, which is 2458. Let's substitute that and see what we get. So 6,67 times 10 to the minus 11, 1250, 5,98 times 10 to the power 24, and 2458 is our force. So r squared is 2,03 times 10 to the power 14, and this is going to be in meters. So r is going to be the square root of that. So the square root of this answer, so square root that is equal to 14,24 times 10 to the power 6 meters.